Yeah, very good morning, students. Today, in this video, we are going to discuss about the problem related to the capacitor charging and discharging. See, the problem is a capacitor charged to 50 volt is discharged by connecting the two plates at t is equal to 0. See, if the potential difference across the plates drops to 1 volt at t is equal to 10 millisecond, what will be the potential difference at t is equal to 20 millisecond? This is a problem. See here, in the capacitor is having 50 volt and the starting time means at t is equal to 0, the capacitor is having the 50 volt. After 10 millisecond time, the 50 volt becomes the 1 volt. The question is, at 20 millisecond, what will be the potential difference? Okay, so let us discuss about the solution of this problem. First, you should consider the general formula for the relationship between the potential charge and capacitor. Actually, this is general uh, equation, general expression for relating the potential and capacitor. See, here we are talking about the charging and discharging in the capacitor. So you have to consider that the Q, that is nothing, Q naught e power minus P by RC. So you have to consider this equation. So if you substitute it in this equation, what you will get, V is equivalent to Q naught by C e power minus T by RC. Right. See, this Q naught by C, this Q naught by C, that is nothing but V is equivalent to V naught e power minus T by RC. So this is a general equation. Now you have to consider the first given data, means at t is equivalent to 10 millisecond, what will be the potential? That potential V is 1 volt. Right, substitute this information in this equation. So 1 volt you are getting, and what is the maximum voltage? That is the maximum voltage at is equal to 0, that is nothing, that is a 50 volt. Substitute here 50 volt. This is the 1 volt only for the V, and for the V naught you have to take the 50 volt, and the remaining you substitute as such. So E power minus, what is the time? That is at 10 millisecond only. So 10 millisecond, right, divided by R and C. That we don't know, that you keep R and C like that. So just rearrange this equation. So what you will get, e power minus 10 millisecond by RC, that is nothing, 1 by 50. So one equation we are getting, one exponential factor e power minus 10 by RC, that is nothing, 1 by 50. You keep this one for solving the second one. For solving the question. What is the question? What will be the potential difference at t is equal to 20 millisecond? So the data given here, t is 20 millisecond. What is the potential difference? That you have to calculate. So again, you substitute this term in this equation. So as per this equation, once again you rewrite that equation. What is the potential? V is equivalent to V naught e power minus T by RC. That's all. Here you can take, we have to find out the V. Okay, what is the V naught? That is the starting initial potential, that is nothing, that is a 50 volt. So you can write that 50 volt as such here. Then e power minus, what is the time here? That is the 20 millisecond. So substitute the 20 millisecond divided by R into C. So V is equivalent to 50 volt. That's okay. Then e power. Now you can rewrite this equation like this: minus 10 millisecond by RC, the whole square. Okay, but that's same. Okay. So you see here already, you know, e power minus 10 by RC is nothing, that is 1 by 50. No? So for V is equivalent to 50 into, okay, 1 divided by 50 the whole square. So 150 and 150, that is a cancel. So 1 by 50, what is that? Take, right. What will be the answer for you? 1 by 50, that is nothing. V is equivalent to what? So 0.02, that's the answer. About 0.02 volt, this is the answer, right? The answer is V is equivalent to 0.02 volt. See here, at t is equal to 10 millisecond, the voltage, 50 voltage, okay, drops into the 1 volt. At t is equal to 20 millisecond, what will be the potential difference? That is V is equivalent, that the potential difference is 0.02 volt. That's all. Okay, let us discuss the one more questions in the next video. Students, thank you so much.